In this video I'm going to be showing you how to calculate the concentration of a weak base. So this means things like ammonia and other things like that, so not your metal hydroxides because they tend to fully dissociate. So this is something where it partially dissociates when turned into a solution. Here I've got 0.0450 moles per litre of ammonia solution. I've been given a pKa for its conjugate acid, the ammonium ion, and I'm going to use this information and a few other things to work out what the pH of this solution would be. The first thing I'm going to do is actually write a balanced equation for the dissociation of ammonia in water, because it's a solution, it's an aqueous solution. Then from this, I can write an equilibrium expression. Because it's a weak base, it only partially dissociates. So I can pretty much assume that most of the 0.0450 moles per litre of this is going to stay there. But enough of it is going to turn into ammonium that it's worth showing the equation. So I'm going to write a K expression for this. Because it's making hydroxide ions, it's a Kb, or a base dissociation constant. And again, just using my knowledge of knowing how to write a K expression for any equilibrium, I get this. Ammonium ion concentration times the hydroxide concentration over ammonia concentration. Now, looking at this equation, I can make an assumption that both the ammonium and the hydroxide are in approximately the same concentration. So I'm going to call that X. So it means that I can rewrite this equation shortly. So I've actually got, these two are going to be x squared, same number times itself, and this one's going to be 0.045. So I know those, but I don't know Kb. So there's another step in here that wasn't present when we did weak acids that I need to do, and this is based around this equation. Kw is equal to Ka times Kb. So because I've got a pKa, I can also do this another way. pKw, which is 14, because Kw is 10 to the negative 14, pKw, 14, is equal to pKa plus pKb. Well, I've got pKb, so that means in this example, the pKb is going to be 14 minus 9.23, so pKb is going to be 4.77, I think I've got this one here. Let's check that my mental arithmetic's actually correct there. So I've got my pKb. That means I can say that Kb is just going to be 10 to the power of negative 4.77. So I can put that in. Now I've got enough information that I can write an equation that will help me solve for the hydroxide ion concentration, because I'm going to need that to work out my hydronium ion concentration to then find my pH. So I've got 10 to the negative 4.77 equals x squared, come up here, over 0.45. If I rearrange this, I get x to equal the square root of 10 to the negative 4.77 times 0.45, and I'll just quickly solve that now. And I get 2.76 times 10 to the negative 3. These are concentrations that I'm looking at here, so I have to remember my moles per litre. And again, if I look up here, it's actually my hydroxide ion concentration, so I might as well put that in there. Now, knowing that, I can use another one of my rules or equations that I have to learn to solve this for the pH. I could find the pOH by going 10 to the negative log of this, then subtracting that number from 14. Or the way that I prefer to do it is I like to use this rule that Kw is equal to the hydronium ion concentration times the hydroxide ion concentration. I know this one here. I know that this one's going to be 10 to the negative 14. So I'm going to go 10 to the negative 14 divided by this number here. And I get 3.62 times 10 to the negative 12. So I'm going to expect my pH to be somewhere in the vicinity of 11 with that, because it's a bit bigger than 12. So I now go negative log of my answer, and I've got a pH of 11.44. So that's in the vicinity of 11 and 12, so I'm pretty good. Sorry, just a step there. pH equals 11.44. So just to summarise the steps here, when you're working with a base, you still show the base dissociating partially in water, and you write a Kb expression. You then have to work out what the Kb value is, because generally you're going to be given a Ka or a pKa in the question. So there are a few more steps in this than solving for a weak acid, but generally the process is the same. If you end up with a pH lower than 7, you know you've made a step or missed a step, so go back and make sure you have actually used Kb, not Ka, in your working.